Welcome to a discussion this morning of Mercury reduction route map and summary. This is a webinar which was held on July 23rd, and it used the route map and summary, which is over 71 slides, to reference additional information which is in the Mercury Reduction Decision Guide. And that Mercury Reduction Decision Guide is also part of Power Plant Air Quality Decisions, which is free of charge to all the power plants around the world. It's also included in the Mercury Air Reduction Markets Report, which is available to suppliers. The webinar included inputs from a number of people from URS, from Babcock and Wilcox, from Chemtura, Cologix, W.L. Gore, and other companies. And the challenge here is to define all the issues and options which are needed to be considered in order to make your decisions about Mercury. And there are even recent Supreme Court rulings which fortunately don't seem to have aren't going to have as much impact as people thought. But you have to define certainly the problem that you're challenged, and then which contaminants that you're going to be eliminating. And there's actually some confusion on particulate mercury because of the fact that EPA failed to regulate particulate mercury, and that may turn out to be a problem. The solutions are based on the type of equipment which is already installed in the plant. If you have wet FGD, you're going to want to take one approach. If you have dry FGD, you're going to want to take another. If you have no FGD, then there's maybe a third option. And of course, EPA originally was relying on the injection of activated carbon in front of fabric filters, but it turns out that there are many different ways that it can be done. So Black & Veatch has certainly been working with a number of companies on the subject. Tom Hart of American Electric Power has been very active within that organization of helping his plants come into line with the new rules. It's interesting that in China that the new zero liquid emissions rules that apply to some cities and provinces are also requiring the mercury reduction. We have actually webinars in Chinese on this subject. Re-emissions is certainly a major problem and one that has to be addressed, but fortunately there are ways of doing it, including activated carbon. So that is one of the reasons that the use of wet scrubbers for mercury removal is becoming more popular, and the reason being that you can prevent the re-emissions, which has been the major problem with using the wet scrubbers. So basically the wet process uses, in many cases, bromine that's injected with the fuel, and that oxidizes the mercury, and you can get very good results. So it's widely used, and the corrosion issues are really probably minimal, but they have to be addressed. And there are a number of papers on that particular subject, such as bromine corrosion impact here that we're referencing. And a lot of there's a lot of information in these PowerPoints refers to, as you can see here where you have these titles, complete presentations that are in some of our other webinars, or case histories, or white papers, etc. One of the interesting things to prevent corrosion is if you're already adding something such as SBS to prevent corrosion by SO3, you are also preventing the bromine corrosion. At least that would be our theory, and we're asking the industry to review that as well. There are non-carbon products such as supplied by Novinda which are small particles that can be injected into the gas stream to adsorb mercury as well. Novinda has made considerable progress with their approach here. And the wet scrubbers are providing very high removal efficiency in a number of instances. And the challenges really are with where you're using just electrostatic precipitators and trying to capture the mercury, and you need a lot of activated carbon, but there are some better carbons out there now, so this is another consideration. SCRs do improve the oxidation of the mercury and allow it to be caught in the scrubber, and Cologix is pointing out that even when you regenerate the SCR catalyst, you don't lose the ability to actually oxidize mercury. And W.L. Gore has an interesting approach where you put a mercury module in after a wet scrubber and can pick up additional mercury removal. And this allows you, and eventually even for the regulatory authorities, to start considering even higher mercury removal efficiencies. Because in the past, it was pretty economical to get 80 or 90% mercury removal, but to get any higher quantity, the costs could accelerate very substantially. This mercury modular approach is a way to get incremental increases at relatively low cost, and it's used in conjunction with wet scrubbers or other mercury devices ahead of it. The measurement of the mercury is a sticky wicket, and we have a number of webinars on that, and they're addressed in the decision guide as well. I'd like to thank you for spending some time learning about the options for mercury reduction, and we welcome any questions you have. This is Bob McIlvaine signing off.